Yeah, thanks. Yeah, thanks. And I'm glad we get the after lunch session. Hopefully people won't go to sleep on us, after lunch, but we'll see. I'll give you a little bit of history about us. So, like, people don't know about Anonymy Labs, but our history is 11 years ago, 5 of us got in a room at the Gold Coast. It was in Surfers Paradise above the bar, and we had this room and we started this privacy company. And since that time, we're focused on building, I don't know if we're a privacy company or an identity company, but we've been building product in this space. We now have about 50 software engineers at the Gold Coast and about 50 people in the US. And the US folks are more sales, marketing, finance, those sort of people. But yeah, we build products in this space. What we're going to talk today is one topic that's kind of come up a lot with us lately, and you mentioned decentralized identity and verifiable credentials. That's one of the areas that we work on in Anonymy. But one of the things that's come up, I would say, over the last year or two is this idea of provenance of data and historical provenance. So what happens when data gets created and what happens when it gets modified, and how do you know all those things? And it's particularly important in the AI world because I think back 2 years ago. It's a long time in the AI world, 2 years. And you think, you remember all those images where they'd have someone and they'd have like 7 fingers. And, you look at an image, it's like, it's not quite right. But then you look at them now and you're like, I really can't tell, right? So there is a whole new area called kind of provenance and content credentials and all that. That's what we're going to talk about today. And just, where did Anonymy start? So we started with this idea of personas, that when you go out on the internet, you should be able to go out as one of many personas, and they should all be individual, and you shouldn't be able to track between them. So that's where the company started. We've progressed since then. And the way we got that idea is that was an identity proxy, right? There was an identity proxy saying Paul shouldn't go out to the internet. One of his 10 proxies should go out and do all the interactions, and they can collect your data and sell the data. It doesn't matter because it's just the proxies. And today we're going to talk more about a privacy proxy, but around kind of AI and images and things like that. So let's go through it. So you look at this image here. Is it real or fake? Right? How do you know? Well, one way to look at it, I can tell I'm in Scotland because there's a Loch Ness monster. There's a unicorn horse. But how do you know it's fake? It's never sunny in Scotland, right? So you know it's fake, right? That's why you know it's fake. Let's go to the next one. Is this one true or is it fake? It sort of gets harder because now you've got the unicorn and there's people interacting with it, and you probably think, well, there's no such thing as a unicorn, surely it's fake. But it is getting much harder, right? It's getting much harder. So there's a lot of work that's happening at the moment. Try to humans the ability to understand if what they're seeing is real, and by real I mean maybe taken with a camera or a video camera or something, or if it's been modified. So, and there's nothing wrong with, we're not saying there's anything wrong with modification. You might take it into Adobe and start changing colors and contrasts, and you may add some AI to it. We're not saying that it's wrong, but what should really happen is a person out there who's looking at it should know what's happened with that image. So this is a problem, right? AI makes fraud easy, fast, and cheap. And we kind of have a stat here that says digital document forgeries increased 244%, which is a lot, just from 2023 to 2024. And I can tell you, like in Anonymy, so in the last week, I've had 2 employees of Anonymy receive really authentic looking messages from me. Like they get these emails, it's a full email trail, it's all perfect. In the old days, you get the spelling wrong and all that. No, it's not like that anymore. It's all AI generated and it's a complete email trail. And the last one that went was to our accounting department and said, please pay this invoice. And it's like, it looked real. It's like Paul interacting with a company, please, and then me to the accounting department saying, please pay the invoice. And the problem was, that was never me. And so they reached out to me and they said, do you want me to really pay this invoice? And I said, don't pay that invoice. So the problem is, even with things like emails that come in and it's got the right images and the spelling, AI is making fraud a lot easier. So SynthID, this is sort of a pretty new Google effort. And it says here, SynthID is a technology developed by Google DeepMind that embeds invisible, imperceptible watermarks in AI-generated images. Right, so this is the idea here is I have some sort of image or audio or video or something, and mathematically we embed a watermark into it. The human shouldn't be able to see it. Like I shouldn't be able to look at it and go, oh, that's been watermarked, but it can be detected by an engine that can understand SynthID. So what that's showing in the video here is where it says blue in the middle on the left there. I don't know if I can pause this. Can I pause it? Yeah, pause it there. What it's really saying on the left, it's saying that it's got watermark on it. The stuff in blue in the middle is not watermarked, and there's some bits there where we're not sure if it's watermarked. But the idea is my human eye can't spot it, but technology can spot it and say, yeah, that actually was synthetically identified. Well, maybe not a synthetically created image, but it was modified. There was an image there and it's been modified. Okay. So what does it allow you to do, SynthID? It allows you to embed watermarks. So the idea is you get an image, you embed a watermark into it, right, to say that there's some synthetic content in there. You can detect it, so you can detect whether it's been, it's got a watermark, and it gives you the ability to verify authenticity. So, in fact, that image there with the, it looks pretty real. If you actually go and ask Google, about that image, it actually will tell you that it's AI generated, and it even tells you, it looks at things like SynthID, or it looks like this other thing called C2PA, which I'm about to talk about. But it has ways. There's mechanisms for deciding whether it's AI, and there's also algorithms. So I'm not going to talk about them, but there's all sorts of systems out there that will look at an image and try to tell you whether it's AI generated or not. I don't know whether that's going to work another year because we've seen the improvement, but it's certainly getting harder and harder to tell. So the one we're going to talk about, the one thing that SynthID said is they're now working on putting their watermarks into this content credential standard. So let me talk about that. So content credentials, I don't know if anyone's heard about those, right? It's actually been around. It started before this big, increase in AI. It started about 6 years ago. And the idea, and it wasn't actually about AI images. It was created because I was a journalist, I made a photograph. What would happen is I'd put it up and everybody would steal it, right? And put it on their sites and say, this is my image. And there was no way for me to say that this was my image. So this idea of content credentials. So it's kind of pre-AI really. And the idea is, and you can actually buy cameras that do this now, is when you create the image, so you take a snapshot, it creates what's called a content credential. It's a verifiable credential, meaning it's a bunch of claims about the photo and it's signed, right? So at any time, if you see that image on another site, you can say to them, this is my image, look, and here's the content credential that goes with it. And it is an open, there's a standard called C2PA, I think it might be on the next one. It's a set of specifications around creating these content credentials. And it's not about saying anything's right or wrong, it's just telling you what the provenance is. So it starts, for example, I'll show you a slide in a minute, but it starts with, say, a camera taking an image, you create a content credential, take it into Adobe and make some changes. Another content credential says these are the changes. I use some AI on it, and you track that. It's not saying that any of those things are wrong, it's just letting someone who's looking at it know that provenance. So that's what it's all about. So this is what a content credential looks like. You see that there? I'll just hold it there. Okay.
Pause it for you when it pops up.
Yeah, pause it when it comes up. You'll see what it looks like, right? What a content. There he goes. Yeah, see that content credential there. So think of the content credential, I call it the manifest, but it's some signed data that tells you about the image. And on that one there, it can tell you things like who created it, when it was created, whether there was the AI involved, and all those sort of things. But the idea is things like images and content gets modified over time. So you need to actually keep a history of this. So they call that the manifest. call all sorts of information there. One of the issues is it can put an identity in there. Now, in some cases, that's good. Like if I'm the journalist and I take a really good photo and it says got my name on it, and then the photo gets shared, you can go, I can prove that it's mine. It's good. But maybe if I'm taking Paul Ashley at home is taking a shot, I don't want my name in it, right? It's kind of, I want some anonymity about it. So you've got to have that decision about it. So it can identify the person creating up the content. And what are some of the limitations of it? And it's actually, this is a pretty good picture here, gives you an idea of what the content credentials is trying to do. The first one is the photo, and then each of those content credentials afterwards is when something's happened to that image. I've changed the contrast, I've changed the colors, I've added an AI part, whatever. And that's what content credentials trying to do. So one of the limitations is it's considered brittle. One of the advantages of the watermark, SynthID, is it's not considered brittle. So even if I copy it, and screenshot it and then put it over here, the watermark goes with the image. The problem with content credentials is if I somehow remove the content credential, you sort of lost it. What's some of the problems with it? It's the platform adoption is still pretty limited. It said the metadata is fragile and there's trust on central authority. So let me just talk a little bit about that. So platform adoption is limited. So at the moment, there's only a few platforms that support this C2PA standard. You'll see people like Microsoft, you'll see Adobe, etc. And they create these content credentials. Currently, no browsers support it, right? So what you'd really love to do is when you're in your browser, if there's an image there, if it's got a content credential, it should be able to tell you immediately what it is. None of the browsers do that. Chrome actually has an extension for it. So if you install the C2PA Chrome extension, you can point it at an image and it'll tell you if it's got a content credential and what the information is. So there's kind of these limitations around that. There's also limitations, I said, around the metadata is fragile. So it can be stripped and corrupted for different reasons. So here's an image that's actually got a content credential embedded in the image. And I can't see it with my eye, but that's there. The problem is if someone screenshots the image or changes the file format or reposts it or something, you sort of lose the content credential. So content credentials almost assume that everyone's playing correctly. So they're doing the right thing, they're looking at it, they make a modification, they add their own content credential, etc. Right. And the last problem with it is to actually sign a content credential, you've got to be on this trusted list. And there's this trusted approvers that you've got to get onto to be actually able to create content credentials. If you sign it and you're not recognized, then it may not be validated. And they oversee, Microsoft and oversee a lot of this. The last one, this is everyone has to put their tinfoil hats on. Everyone puts a tinfoil hat on now. The other thing that people have been raising is there's been a lot of Defense Department interest in content credentials in the United States. The theory being is they'd love all of us to create all of our images with content credentials so they can track people and know what they did. And so if you take I've taken a photo at a protest march, so it's already got a content credential, they know that was you that was there, etc., etc. So tinfoil hat says there's challenges with opting out of this and whether there's people want to use it for kind of malicious reasons. Okay, so what do we want to do? It's a lot of history about kind of what we wanted to do was create a system for allowing a user to be able to determine whether a photo was original or synthetically modified, but doing it in a private way, right? So we want to do a privacy preserving approach to it to see whether it's generated or modified. The user should be able to have anonymity to do this. So the problem of calling into a system to check it is, well, they kind of now know that you're looking at this image. So we want to get away from that. We want to avoid tracking the user's activities. We wanted a decentralized solution. What we mean by that is we wanted to be able to put it somewhere that anyone could go to it, highly reliable, high integrity environment, but there's no tracking on that as well. So that's the decentralized part. And allow the user to pay for the service. So if you want to use this more privacy preserving way, allow you to pay, and that's kind of the micro-credentials to do that. And allow support for multiple AI detection techniques. One thing we realized when we're kind of researching this area is SynthID have got the mathematical ones, content credentials doing something else, and other people doing other things as well. So it's probably a moving area. So if whatever we need to do here, we need to be able to support the change in the industry. Yeah. So I'll go through this really quickly because I'm going to use up all the time here. So one of the things I said we do in Anonymous is we do verifiable credentials, or people call it decentralized identity. If you have a look at it, what it does, that picture that kind of explains it, is an issuer, so that could be the camera, issues a credential to a holder. That could be, that could be a file system, but it's usually a wallet that a user's holding, and at any time you can present it and be verified. And content credentials, you could look at it as a subset of verifiable credentials. It's just a certain use case for them. And there's cryptography there. One of the privacy preserving techniques is I should be able to present that and have that image and a content credential verified without ever having to go back to the issuer to say that. And so there's techniques around that. I won't talk too much more. I'm going to use all of Max's time up. The last thing, and this is the checked part. So one of the things we do in Anonymous is we help run a network called the CHEQ network. So it's a blockchain or a ledger that's used specifically for decentralized identity as a kind of a trust layer. They also have this capability called DID linked resources. And so this allows you to actually add to the blockchain in a way that's highly reliable, highly available, integrity protected, and only the controller can change it, so the person that put it up there. So this is a technology we wanted to use for this. And I won't go through the technical details. I'll let Max talk a little bit more, but I think it's time I hand it over to Max, I think.
Sure thing. And I might just leave the microphone to
Okay.
this.
Hey everyone, so yeah, I'm going to go a little bit into the more nitty-gritty side of it, even though we already kind of went into a lot of detail, but there's some reasons how we can solve this, or ways that we can. So we shift from fragile metadata-based provenance like C2PA to cryptographically verifiable credentials anchored on the chain, so on the CHEQ network. So instead of relying on content creators to embed the truth, we empower users to request an on-demand scan to pay with a microtransaction. So the CHEQ token also is kept track of on the blockchain, just like most other cryptocurrencies. And then we'll, at the end, receive a signed proof stored as a DID linked resource. Now you'll hear me repeat this again. It's basically just a glorified Dropbox that can't be tampered with. And you have to pay for it, just like Dropbox, I guess. So this approach survives screenshots and re-encodings, broken metadata, because the trust is no longer embedded. It's verifiable. So we're going from like a bottom-up approach instead of a top-down, where the person who creates doesn't have to embed it inside, though we go back and verify anything that hasn't or has got content credentials in it. So I've got just a proposed privacy proxy ecosystem is what we've just come up with. And I'll go over a comprehensive technical overview of the system architecture and a detailed walkthrough of how verifiable credentials can solve this. So little system architecture diagram, and then verifiable credential little walkthrough before a partial demo. So we'll go with a high-level system architecture. So first, it's a browser extension for Chrome. It's got a UI pop-up for like service and network connectivity status, pretty stock standard like extension things. It shows us at a glance whether the extension is online and the active scan statuses. There's a context menu action, so you can right-click on an image and go scan this image. Then a crypto wallet, a secondary crypto wallet, either on your phone or another browser extension, will request for the payment to be processed. Then there are background workers in Chrome, which constantly scan all the images that are coming through your network and will create hashes of them, essentially. Then it interfaces with the CHEQ blockchain, where we do payment token transaction processing. And the issuer did, which is the identifier for, I guess, the source of truth, who puts these verifiable credentials on the blockchain. That's the source of truth that can't be tampered with. That's how we know we can trust it. And then to link resources, as I mentioned, I'm going to speed run through this a little bit. So no express backend, which will expose some APIs and do some image processing on its end as well. Then a MongoDB storage and Redis for really fast job prioritization, because as you may imagine, that's a lot of images coming through all the time. It's like you go on a web page, there's maybe 100. You scroll on Pinterest, there's thousands, anything. So, let's get all the slides up there because that was a little bit broken. So the user starts off by requesting a scan, and that initiates the Web3 payment. Then you have to do the transaction approval on the other wallet where you actually store your tokens. So the browser extension itself doesn't have tokens in it. It's like a hand-in-hand transaction. You approve, and then the backend receives the request, and it will wait and check blockchain independently for that transaction to be processed. Then it's going to go and do some AI detection. So funny that we're combating AI with AI. I think that's going to be a common theme in up and coming. Then we will create a verifiable credential out of the scan results that came out of these AI methods. Then very lastly, well, almost, we'll anchor it on the blockchain so that anyone else who has seen a similar image would be able to get that scan result as well for free. So that's the benefit, is that if one person pays for it, there's an AI scan result, and then everyone else gets to see it for free. Pretty cool. Key benefits, yeah, the Web3 payment confirmation, it's all on-chain. There's no need to pay your Visa, MasterCard, anything. If you've got tokens in your wallet, you might be able to set it to auto-approve. Depends what you're, yeah, what you'd like to do. So just to go to the next slide. So I'm going to walk us through the credential subject. So this is like the image metadata. This might give you a bit of an idea of the problems that we might face with this kind of architecture. And just in general, like if a photo is up on a website, there's nothing to say that it's just going to go down. It could disappear. Then how do you you can't resolve the URL anymore. Okay, we might have it at archive, web archive. That's a quick solution, or better yet, possibly another blockchain. There's many, there's many out there, but we'll be using cheqd and did linked resources, although there are some limitations of about 10 megabytes on a did linked resource. So we need to find alternative ways to also store large images. Some go in the size of gigabytes because they're really large images. And the interesting thing here is that it's not an exact hash, because as you may imagine, we would face the same problems that C2PA did, where if it's not identical, then it's could have been tampered with. You can't prove that this image and that image are the same. So we do this architecture proposes a perceptual hash, which is kind of like a similarity index or a confidence score that this image and that image are the same image. So that then enables us to just find those images already on the blockchain that somebody else scanned for us with their own tokens. Yep, tamper-proof, long-term preservation, so storing it in a permanent location, probably important, and then duplicate detection and matching. So I'm going to walk through the W3C credential structure. So W3C is just an open standard, and they define ways, and so do schema.org, of how to essentially build this kind of structure but it's very open and it's very flexible. And so I've gone ahead and designed my own synthetic content scan, which I'll walk us through. So a synthetic content scan credential also has this issuer, which is here. This did check testnet is the anchor on the chain where we always know that that's the service that is providing the AI scan capabilities. So, and the credential subject is the main interesting part that we're probably all waiting to see. So let's say I've got another photo here. It's another unicorn, but is it the same? Did it was it made by the same model as the previous one? Let's find out. The C2PA credential scan says, okay, there's a C2PA manifest embedded inside this PNG. Great. Says that OpenAI generated it, and it's a DALL-E 3 model that generated it. Then SynthID would be like, no, this is an AI, because SynthID wasn't particularly trained on this specific, or more so, the SynthID watermarks were not embedded in the photo, unlike from Gemma products, Gemini, that is always embedded inside. Then there are also custom models that there are many out there. This is one example of FDXL, which is for stable diffusion, extra large. And this is a particular model that was actually trained on a set of generated images against some image pairs. So it was able to identify the artifacts in between the real images and the fake images, particularly for stable diffusion, or more so for the artifacts that these models create. So in a summary, we would get something like this, where it says, okay, 1% SynthID, so there's a chance that it's not made by Gemini, not made by Gemma. But the C2PA manifest shows us that it does have a content credential in it, and it even claims that it was made by DALL-E 3, as we saw before. And then the AI model, or ML model, sorry, also detects that it is 97% generated, AI generated. And in this case, it didn't pick up anything because it wasn't a SynthID generated image. So I have a live partial demo that that I will try and demonstrate now. Bear with me as I change my screen share, or better yet, let's bring up. Surely I can go across to the other screen. Nope. Okay, let's exit the presentation and change the screen share. Please bear with me. Screen. And there we go. Yep. Sorry, technical difficulties. And here I have Brave browser, which is essentially Chromium, for the sake that it was a fresh install and I didn't want to interfere with my Chrome build. This is the testnet, so I'm not this wealthy in cheqd. It's actually just testnet tokens, which have no value. But this is the Leap wallet, where you would actually connect with the extension. So I'm going to load the extension from the folder, and we can open it up on created A. So this was, I'm sure some people have played around with the AI Studio, the Google AI Studio. This was just generated from that. And I wanted to prove that you could right click on any photo that was potentially AI generated or not. And then it would request an image scan, request for your Leap wallet to connect, which unfortunately, apologies, in this demo, I do not have the Leap wallet connecting, but I do have a local dev server up, which should do the payment or the image scanning, which unfortunately, again, the demo gods are not with me today, but please stay tuned and I will post it on LinkedIn as soon as it is working. So I appreciate your patience and I, again, apologize for that. So I'm just going to continue because the future is really exciting because, oops, not from the start. The future is really exciting and Sure, yes. So the current demo only really demonstrates images, especially just in a web browser, but most of us are on our phones. There's a lot of room to improve. So you need to be able to scan videos and all kinds of content. So yeah, exactly. Multimodality is a big topic, and I don't think many companies or anyone has really explored that as much because it is very new and it's a race to try and battle versus avoid. And there's a lot of other ways that you could essentially use these AI scanning capabilities to do things like PDF deconstruction, scan singular images in the PDF, and scan text, which SynthID also does, and fact-checking and citation validation, so on the cards, and OCR for reading like text inside of an image, because that, if you imagine, you could bypass any kind of AI scanning techniques by just getting your AI generated text, paste it on an image, and then upload it, and then the scanner, which is designed for text, will not pick that up because it's a different medium. Yep, so current demo, Chrome extension, Firefox and Safari. Ideally, it'd be great to have something like this built in, so we don't have to rely on external parties and can just have trust inside browsers. Maybe we'll get there. So cross-platform support as well, like I mentioned, phones is probably the more viable use case for this kind of technology, just with the demo, time limitation, and yes, CTP manifest. Sorry, I ran through that a bit fast, but thank you.
Any questions for this?
You mentioned you're looking at multi-modality, and I was just thinking in terms of social media and that. Would you be looking at how do you integrate native TikTok, Instagram, Facebook deals? Because some have AI generated images.
Yep, absolutely. And I'm glad you raised that because that's exactly what I had in mind with the iOS or Android capabilities. TikTok recently did they do scan C2PA manifest files, and they will automatically detect or mark AI generated content, but there is also an opt-in field to turn it off or on. So it's a little bit problematic. I think it's just a bit too early, and these kind of conversations are going to, I guess, raise the bar on what is accepted online for trust. So thank you.
Does anyone else have any questions? No? Oh, well, thanks. A big hand to these guys. I actually found that talk really, really interesting. I think with this massive surge in AI-generated imagery, the need for this is growing each and every single day. And I really like the way that you guys have applied that to blockchain as well, to create that extra layer of authenticity and verification. So I know I found that very interesting. Thank you so much, guys, for bringing this very valuable information to us. Give them a big round of applause, please. Thank you. Here's a little